Hey everyone, welcome to the last lecture week of General Chemistry 2 this second semester. I know there are already lecture videos in your LMS for this week, but I just want to make this lecture video to summarize the general steps in balancing redox reaction equations. So in this video, I will no longer discuss how to balance neutral redox reaction equations, but rather I will be focusing on the basic and acidic redox reaction equations on how to balance them. Okay, so when we say redox reactions, redox simply means oxidation reaction. Okay, so this is a process where, or these are reactions where electrons are being transferred from one species or substance to another substance. And this transfer of electrons depends on the species or substance's reduction or oxidation potential. Okay, and just like normal chemical equations that we know, redox reactions can also be balanced. And we are considering two important things in here when we balance them. First, there must be a balanced number of atoms of the elements found on both sides of the equation. And second, there must be a balanced charges of the reactants and the products. Okay, so let's begin with the basic redox reaction. Excuse me if I'm going to speak in Filipino because I think it would be a better way to teach or to introduce some of the terms in here or the steps. Okay, so for basic redox reaction, we're going to take one of the examples found in your LMS. So iodine plus ClO3 yields I3 negative plus Cl negative. As you can observe, there are assigned charges in each of the substances. Okay, so the first step in balancing basic redox reaction is to get the first half of the original reaction. And then you balance the number of atoms of the elements and their charges. Okay, so for me, I will start with the substance with no oxygen first. Or others would also begin with using the first half of the original reaction with the first substance seen in the equation. So in this case, it's the iodine atom. Okay, so if you are going to get the first half of the reaction, you must get one substance from the reactant side and the equivalent substance of that on the product side. So in this case, if you started with iodine, of course, the first half of the reaction will be the I negative on the reactant side and I3 negative on the product side. Do not include the ClO3 and Cl yet. Okay. So, as the first step said in here, that we must balance the number of atoms and their charges. Okay, so let's check. The charges on the reactant side in here is -1 because there is a negative in here. And on the product side, it's also -1. So there's no problem on the charges because it's already balanced. But when it comes to the number of atoms, as you can see, there's only one iodine atom on the reactant side, but there are 3 atoms of iodine on the product side. How come that it's 3? Because of the subscript 3. Okay, so as you can see in here, it's already unbalanced. So as a review on how to balance chemical equations on our previous topics during Gen Chem 1, you just have to change the coefficients. Okay, so we are therefore going to put 3 as the coefficient of the reactant in here to make the number of atoms balanced. Okay, now as you can observe, the charges changed when we added coefficient in here. Why did it become -3 on this side is that in order to count the charge of the substances, you simply multiply the coefficient and the exponent or the charge that is found in here. Okay, so that's 3 times -1. That makes -3 as the charge. And then on the other side, since we didn't add any coefficient, the charge remains the same. Okay, so what are we going to do to make these two equal? That is, you are going to add electrons. Okay, so that's why it's a redox reaction, because we could simply add add electrons to make the equation balance. Okay, so we need to add 2 electrons on the product side to make the charges equal to -3. So if the reactant is already -3 and we added 2 electrons on the product side to make it also -3 on the product side. So if the charges and the number of atoms were already balanced, then the first half of the reaction is already correct. So this will be used later on when we combine it to the second half. Okay, so the second step is to get the second half of the original reaction, the substances that we didn't use a while back. So we treat the equation as an acidic reaction by adding water molecules depending on the number of oxygen atoms present on one side of the half equation. Okay, so the second half that I am talking in here are the substances that we didn't use a while ago. That is the ClO3 negative and the Cl negative on the product's side. So it says in here that we need to add water molecules depending on the number of oxygen atoms. So since there are 3 oxygen atoms on the reactant side, meaning to say we also need to add 3 water molecules on the opposite side or on the product side. So if you find oxygen atoms on the reactant side, then therefore it's going to be on the product side that you are going to add water molecules. So in this step, take note that the number of oxygen atoms will be equal to the number of water molecules that you are going to add. So since there are 3 oxygen atoms in here, we also added 3 water molecules. So after adding water molecules, we add this time hydrogen ions on one side of the equation depending on the number of hydrogen atoms of the recently added water molecule. Okay, so we need to add hydrogen atoms based on the hydrogen atoms of the water molecule we recently added. So we are going to count in this step the number of hydrogen atoms found in the water molecule that we added. So since we added 3 water molecules, the number of hydrogen atoms found in there, therefore, is 6 hydrogen atoms. So the number of 6 hydrogen atoms will also be the number of hydrogen atoms that we are going to add on the reactant's side. Okay, because the hydrogen atoms are found on the product side. So the 6 hydrogen ions will be added on the reactant's side. Okay, so on step 3, take note therefore that the number of atoms is just equal to the number of hydrogen ions to be added. Next, after adding hydrogen ions, we are now going to add OH ions on both sides of the equation depending on the number of recently added H ions. Okay, so connected pa rin siya. So it says in here that we need to add OH ions depending on the H ions that we previously added. So since we added 6 hydrogen ions, automatic mag-a-add din tayo ng 6 OH ions. Take note, on both sides. So 6 OH ions in here and 6 OH ions on the product side also. Next. After adding OH ions on both sides, On this step 5, we need to combine the OH negative and H positive ions to produce H2O molecules. So that's already given that when you add OH negative and H positive, water will be produced. So here is the equation a while back. So we already have 6OH negative, 6H positive, and then ClO3 negative on the reactant side. So on this step, it tells us to combine OH negative and H positive. So they are found on the reactant side. Therefore, this will become 6H2O. Take note, you retain the coefficient. 6H2O, and then you copy the rest of the equation. Okay, after combining OH and H, there will be H2O molecules found on both sides of the equation. So if there are already water molecules on both sides of the equation, you simplify it by subtracting the lesser amount of water from the larger amount of water molecule. So the equation now that we have in here, after combining on the fifth step, is this. We have 6 molecules of water on the reactant side, and we also have 3 water molecules on the product side. So we need to subtract 3 water molecules to both of each sides. Okay, so 6 minus 3 in here. So that will become 3H2O because 6 minus 3, and then you copy, bring down the other substances that are not affected, and then of course we simply cancel this and then bring down the unaffected substances. Okay, so this is already simplified. Next, after subtracting or simplifying the equation by subtracting water molecules, we need now to balance the charges of the second half by adding electrons to the appropriate side of the equation. Okay, so in this equation now, as you can see, from the result of the equation on step 6, we have 3H2O plus ClO3 negative yields Cl negative plus 6OH negative. The number of charges on the reactant side is negative 1. Why negative 1? Kasi ito lang po yung charge. If there is no charge found in here, that means 0 kapag walang charge. But if it's negative or positive, that means 1. And then on the product side, it's negative 7. Why negative 7? Because as we mentioned a while back, you count the number of charges by multiplying coefficient and the exponent or the charge. So this is negative 6 on this side plus negative 1 for Cl ion. That would be negative 7 on the product side. So it's obvious that they are not yet balanced in charge. So what are we going to do to make them both negative 7? So obviously, we need to add 6 electrons on the reactants side to make both of the charges equal to negative 7. Next is to combine the first and second halves of the reaction, adjust the number of electrons if necessary. So on our first step a while back, we already solved for the first half of the equation, and on step 7, we already solved the second half of the reaction. So on step 8, we are now going to combine these two. Now in combining the two, you need to take a look at the number of electrons added in each of the reaction. On the first half, we added 2 electrons on the product side a while ago. And on the second half of the reaction, we added 6 electrons on the reactant side of the equation. Now, in this step, we need to cancel out the number of electrons in here by making them the same. Okay, so since the first half has 2 electrons in there and the second half is 6. So to make them equal, we need to multiply the first half by 3. Okay? So that it will become 9i negative, because times 3i negative times 3 is 9i negative, yields this one, 3i3 negative plus 6 electrons. Okay, so it's 3 times 2. So this is now what we are going to use as the final first half of the reaction. Okay, so if we are now ready to combine the first and the second half of the reactions, okay, you need, don't forget to cancel the electrons in there, okay, and then you now write for the final answer all substances that are found on the reactant side and all the substances that are found on the product side, still separately, of course. So if you are now going to write all the substances found in here, that will be equal to 9i negative plus 3H2O plus ClO3 negative yields 3i3 negative plus Cl negative plus 6OH negative. So this is now the final balanced redox reaction of this basic reaction. Next one is how to balance acidic redox reaction. So I am going to take this example. Zn plus BrO3 negative yields Zn2 positive plus Br negative. So just like the basic redox reaction step, first step is also, I should say, to get the first half of the original reaction. Again, you balance the number of atoms and their charges. Okay, so since zinc in here is the first element and oxygen is found on the second substance, then I will start my first half with this. So zinc and then zinc also on the product side. So the first half is there. Now we compare the number of charges and the number of atoms of each substance. So on the reactant side, there is no charge for zinc. So that's 0 charge. But on the product side, it's positive 2. Their number of atoms is already balanced. They are both 1. So no need to touch that part. So no need to adjust, I should say, the coefficient. So we are going to make the number of charges equal. Okay, so take note, electrons is what we are using in here, not the protons. Okay, so to adjust these charges, of course, we are going to change that positive 2 to make it 0. Okay, so we add 2 electrons therefore on the product side, so that positive 2 plus negative 2, that would be equal to 0 for their charge. So the first half of the reaction will be Zn, yields Zn2 positive plus the 2 electrons. So this will be used later on. Next step is to get the second half of the original reaction, usually with the substance with the oxygen. Treat the equation as a basic reaction by adding water molecules depending on the number of oxygen atoms present on one side of the half equation. So the second half will be the BrO3 negative and the Br negative. Okay, so as you can see, we need to add water molecules depending on the number of the oxygen. So then, since there are 3 atoms of oxygen in here, eventually we also need to add 3 molecules of water. And then again, take note that the number of oxygens will be the same with the number of water molecules that you are going to add. The next step is to add H ions on one side of the equation depending on the number of hydrogen atoms of the recently added water molecule on step 2. Okay, so the equation a while back is BrO3 negative yields Br negative plus 3H2O. So we need to count the number of hydrogen atoms on this side. So there are 6 hydrogen atoms, meaning to say this is also the number of H ions that we are going to add on the opposite side. So 6H atoms in here. So we are going also to add 6H positive ions on the other side. And take note in here, the number of atoms will be equal to the number of hydrogen ions to be added. The next step is to balance the charges of the second half by adding electrons to the appropriate side of the equation. So this is now our working equation. So we have 6H positive plus BrO3 yields Br negative plus 3H2O. So the number of charges on the reactant side is positive 5. How come? Because 6 times 1 positive is positive 6 in here plus negative 1. So 6 plus negative 1 is positive 5. And on the product side, it has no charge for this one, but it has one charge, negative charge for Br, so that's negative 1. And then don't forget also to check the number of atoms if they are already balanced. For hydrogen, they're both 6 already, bromine 1, and oxygen both 3. So no need to change the coefficients of the equation. So all we have to balance is the number of charges. So how are we going to make positive 5 equal to negative 1? So we need to add 6 electrons on the reactant side to make it negative 1. So that positive 5 plus negative 6, then that would be negative 1 to make it equal to the charge on the product side. So if the number of charges and the number of atoms are already equal, then the second half of the reaction is already correct. Step 5 is to now combine first and second halves of the reaction. We need to adjust the number of electrons if necessary. Okay, so the first half a while ago was this one, and the second half, the one that we have computed on step 4, is this one. So notice that the electrons are not yet the same. So we need to get the least common multiple, which is 6. So we need to multiply the first half by 3 to make it 3Zn yields 3Zn 2 positive plus 6 electrons. So if you are now ready to combine the two half reactions, this will become, this will result to these two equations. So again, you cancel 6 electrons and then bring down all the necessary substances on the reactant side and all the necessary substances on the product side. So the final answer for this equation will be 3Zn plus 6H positive plus BrO3 negative yields 3Zn2 positive plus Br negative plus 3H2O. Okay, so for you to check if your answer is already correct, you may count the charges and the number of atoms of each side. Now, to sum it up, here is the difference between the basic and acidic redox reaction. So, kung makikita nyo, steps 1 to 3, they are both the same. Okay? First step in solving both basic and acidic reaction is to balance their number of atoms and the charges of the first half. Then after that, you need to add water molecules, okay, depending on the number of oxygen atoms. So again, nakadepende ang number of water molecules na idadagdag dun sa oxygen atoms na meron yung isang side. Okay? And then, step 3 is to add hydrogen ions. Where will it depend? It will depend on the number of hydrogen atoms of the water molecule you recently added on step 2. So kung ilan man yung number of hydrogen atoms ng water molecule na inad mo kanina, yun din yung number of hydrogen ions that you are going to add on this step. What makes basic and acidic redox reaction different is steps 3, 4, 5, and 6 of the basic redox reaction. Kay acidic reaction kasi, hindi na kailangang mag-add pa ulit ng OH ions, hindi na kailangang makaproduce pa ng water molecules from the combination of OH and H, at hindi na kailangang mag-subtract ng water molecules on both sides of the equation. So, wala na yun kay acidic. Pero they will be again the same on solving for the second half, or I mean on the balancing of the second half of the equation. So you need to balance the charges on the second half by adding electrons. And then lastly, you combine the first and second halves, you adjust the electrons if necessary, cancel out the same amounts of electrons. So ganun lang yung steps. Kay basic redox, una, kunin mo yung first half, i-balance mo si atom, tsaka si charges. Pangalawa, mag-add ka ng H2O, depende sa number of oxygen atom, meron yung isang side. Pangatlo, mag-add ka ng hydrogen ions, depende sa number of hydrogen atoms na meron dun sa inad mo kanina sa step 2. Pang-apat, you add OH ions depending on the number of hydrogen ions you added on step 3. So dito na step, parang pare-pareho yung tatlo na i-add mo eh. Kung ilan yung hydrogen atoms ni H2 molecule na nilagay mo, ganun din si H ions, ganun din si OH ions. And then after that, you combine OH and H to produce H2O. And then since my H2O on both sides of the equation, you subtract the lesser amount of H2O to the larger amount. Okay? And then, para makancel yung isang water molecule sa isang side. And then, you balance the second half by adding electrons to the appropriate side. And then, lastly, you combine the two halves of the reaction. Sa acidic redox, mag-balance sa first half, mag-add ng water molecules, depende sa oxygen atoms, and then mag-add ng H ions, depende sa number ng H atoms meron dun sa water molecule na kaka-add, and then you balance the second half by adding electrons, and then finally you combine the first and the second halves of the reaction. So I hope you understand how to balance basic and acidic redox reactions. Please feel free to message us, your teachers, if you have any questions about this lesson. So again, thank you for watching this short video, and I would like to inspire you with this. You must keep going because you're almost there. Guys, this is already the last week of lecture video. Natapos din ang semester na to, natapos din ang General Chemistry 2, so there's no reason for you to give up at this moment kasi patapos na tayo. Exam na lang ang inaantay. So, God bless everyone. Again, if you have any questions, please feel free to message us. Thank you so much and good day.